Okay, here we have a spreadsheet, and I've already filled in our differential equation, and then we'll be able to change initial values here and change step size. So I haven't filled that in yet. I went ahead and solved the differential equation just by direct integration, and I got t squared plus t plus c, and then I went and used the initial value given in the original problem, 0 and 1. So let's actually put that right here, 0 and 1. And so I got the exact solution is t squared plus t plus 1, because we're going to figure out the error and we're going to use that to compare. Now I have, if you go under numerical analysis link on the home page that said sample from sample of Euler's method in Excel or something like that, and I have this there. So if you want to use this as a template to get started on yours, that would work. You're going to need to modify it for different things you're asked to do, but it's a good basic start. There's two tabs. One is the program, and I don't have anything filled in on it. I don't have the DE filled in. I have this part, but I leave this part blank so you can fill in the pieces and use the template. And then I also have the solutions tab where I have the solutions to this one. All right, so what we're going to want to do is initially we're going to put for h, this is h is the step size, how far apart our t intervals are, and this is going to be 0.5. All right, we got our initial value in, and so this column is going to be our t sub n's, and this column is going to be what Euler's method computes for the y sub n's, and then this column is going to be the exact solutions y, and then this column will subtract these two to get the error. So let's go ahead and do things to get that. Here I'm going to start with my initial value, and so it'd be a good idea, rather than to put in 0, to put in this cell right here, because then if I change this, that will automatically change. So in order to do that, you type equal and then you click on the cell you want, which would be right here. So it tells me B5. Equal means you're making a formula. Now when I hit enter, it applies the formula, and so now if I go change this initial value to say 0.1 or something like that, you can see that it changes it down there. So that's why it's good to make this dynamic, so it'll work for whatever initial values you want, whatever step size you want. Okay, for this next one I'm going to hit equal because I'm going to make a formula, and I want to take the first value here and then I want to add to it the step size. Now one of the things that I'm going to need to do here is, if I have it repeat, it will go then to, it'll move each time and it won't keep the h value of 0.5, it'll increase that. So if you want to keep those fixed, you put $signs in front of both the column and the row. Now it'll always pull from that one, but when I click to drag this down, it will move down a cell and use the one before. So let me show you what I mean. So the next step's 0.5. So when I drag this all the way down, it builds all of my intervals. And so if there's one that you want, so as I see this formula, it's not actually showing here, I double click it so I can see it. It's going to use the value from B10, the one above, and it's going to add, because of the $signs, the 0.5, and that's going to stay fixed. Otherwise that would have moved as well. So that's the formula you would want for that. Okay, so now we have all of our t's. We're going by 0.5s all of the way up. So now we want to compute our y sub n, and the formula is you're going to take the one in front, and then you're going to add the width of our interval, which is 0.5, and then times, this is putting that t in our differential equation, which was 2t plus 1, so 2 whatever value we're on plus 1. So we're going to program it to do that, but actually our first y sub n is just going to be 1, but we're going to pull that from, we're going to hit equal, and we're going to pull it from here. So again, that will change if we change our initial values. So this is going to be our initial values. Okay, so now I'm ready to do the formula to use Euler's method. I'm going to hit an equal sign. I'm putting in this formula right here. So I want the y from the point before, which is going to be right here, plus I want the h, and the h is right up here, but I want that to stay fixed for all iterations, so I'm going to put dollar signs in front of the column and row. Now, there's no implied multiplication, so I need to hit this shift 8, which is the asterisk, which is multiplication in Excel. Then I'm going to make a parenthesis 2, and I need to hit that again because it's multiplied by the t before, which is right here, and then plus 1, and finish the formula. So there is my formula to compute Euler's method, and it's using the tn minus 1, yn minus 1. So I'm going to hit enter. And now I'm going to take that, and if I just get on this little box at the corner, I can drag that down and it will apply that each time. So there are my values of what Euler's method would approximate for the y's. Now let's go ahead and program in the exact solution, and then once we have that, we'll take the difference between those to get the error. Alright, so here for the exact solution, I use the t value squared plus the t value plus 1. So I'm going to hit equal, and I'm going to take the t value, and I'm going to hit the shift 6 to get the squared, and then plus, and I need that t value again, and then plus 1. Okay, so that should compute it for the first one, and then I can get that little thing and drag down so it'll do iterations. And so there's the exact values. And now the last thing I want to do here is to compute the error. And so to compute the error, I'm going to just hit my equal, and I'm just going to do, let's do the original minus the estimated from Euler. And then, of course, because we were on our initial value, there was no error there. And then this gives me the error in each step. So this is how you would use Euler's method. Then you're also going to look at the error graphically, and the lab goes through kind of how to insert a chart to do that. Now I just went in and fixed this formula because it didn't show that implied multiplication that needs to be explicitly stated here after the 2.